Hi, my name is Greg Wallace, um, part of the cohort here with current trends in exercise. And today's discussion is all about exercise and neurological diseases. Um, we're going to talk about today. Um, First, give some brief definitions about what exercise is and what neuromuscular disease is. We're going to talk about some case studies associated with how exercise affects neurological diseases. Um, so, without further ado, let's get started. So, we all know that skeletal muscle is the um, most abundant tissue of the body. And with skeletal muscle, there are physiological adaptations associated with exercise and how it can increase um, muscle size, muscle strength, muscle definition. Um, but what we don't fully understand is how exercise affects or helps or aids in the quality of life of those living with muscle wasting disorders. We know that exercise again benefits us by regular exercise benefits us by causing muscle strength, um, an increase in muscle size and mass. So a rough definition of exercise is any activity that elevates the heart rate, triggers perspiration, and exchange of gases, leading to an increase in physical health and well-being. So anything that causes you to work harder, um, to stress your heart, to stress your lungs, cause perspiration. We know that the byproducts of exercise is carbon dioxide, heat, and water. And so, um, roughly. And then muscular disease is a disorder that causes muscle weakness, muscle wasting, chronic fatigue, and an inability to do daily functional activities. Some things we're going to discuss today as far as muscular diseases are Duchenne's muscular dystrophy, Becker muscular dystrophy, limb girdle muscular dystrophy, polymyositis, amyotrophic lateral sclerosis, and sarcopenia. Um, Sarcopenia, I put that in there purposefully, and I'll tell why later. Okay, so some types of muscular disease. Duchenne's muscular dystrophy is an X-linked or X-linked recessive disorder, meaning that it is more linked to males than females. It typically has an onset of at 3 to 5 years of age. The average person who has Duchenne's muscular dystrophy um, dies by the age of 35, uh, usually leading to death by the age 15 or 18 years of age. Um, they become non-ambulatory so that they struggle to walk. It's a rapidly progressing disorder where you see a change in their gait from the change in the waddling of the gait. From the change in their gait, um, they lose functioning of the muscle. So again, this here is a muscle wasting disorder. Uh, Becker's muscular dystrophy is similar to Duchenne's, but it's not as aggressive as Duchenne's is. So you have the same similar onset. It's also an X-linked chromosomal recessive disorder. You have the same waddling, same fatigue, uh, symptoms associated with this disorder. Here's what you would find with someone who is a young person who has Duchenne's and or Becker's muscular dystrophy. And I would highly encourage you to also subscribe to the Muscular Dystrophy Association and make some donations to the Muscular Dystrophy Association. All right, so some other types of muscular diseases, limb girdle muscular dystrophy. Uh, this here is a muscle wasting disorder that primarily affects the hips and shoulders. And just like Duchenne's and Becker's muscular dystrophy, There's no known cure for these disorders. This is what you would see with someone living with limb girdle muscular dystrophy. Notice that you don't have muscle definition in the shoulder joints, and we also have polymyositis, which is a muscle wasting disease that causes muscle weakness, and is due to an unknown or uncommon inflammatory disease, or is known as to be an uncommon inflammatory disease, and it affects both sides of the body. You notice that in this individual, it wasn't unilateral, but it was bilateral muscle weakness in his shoulder joints. I'm sure that if they had a full body picture, we probably would see something similar in his hips. Amyotrophic lateral sclerosis, also called ALS, Lou Gehrig's disease, is a progressive neurological disease that causes muscle weakness and deformity. All and it's common for people aged 50 or older. The unique thing with all these muscular dystrophies is the chromosomal link. Is that they're primarily X-linked disorders, and secondarily, which makes them more common for men. Here's someone with polymyositis. Notice that he has very weak shoulders, weak hips, and then this is someone with ALS or Lou Gehrig's disease. You know, the reason why I am so passionate about the discussion of this here topic is because of the quality of life of these individuals. We all expect, those of us who don't have these disorders, expect to live later into our years, to our 60s and our 70s, even 80s or 90s. But the life expectancy of someone living with a muscle wasting disorder is 30, 35 max. 15 to 18, they're usually dead. Sarcopenia, on the other hand, is the natural progression of life, where we have the natural degradation of muscle, leading to frailty, leading to things like it has certain endocrine functionalities that cause abnormalities in the thyroid functioning, insulin resistance, neurodegenerative diseases like it also affects our motor neurons. As we age, we know that we don't move as swiftly as we did when we were younger age, in our 20s and 30s. So it's just a natural progression of disease. Inadequate nutrition or malabsorption of the foods that we consume. You can see this in as we age. We also have an abnormality or change in our sex hormones, change in dysfunctioning of how active we really are, and disuse, physical inactivity, and zero gravity, all things that affect sarcopenia. Now, I wanted to throw this in here to talk about, okay, well, what's actually happening in the muscle? On the left here, you see an untrained individual. Okay, this here is skeletal muscle. These here are satellite cells. Okay, so as we, in an untrained individual, as we train, we start to recruit and infuse more satellite cells, which triggers muscle hypertrophy. In a previously trained individual, it's more of a rapid progression, where you go from this detrained state and then you start training and you get the satellite cell recruitment and an increase in muscle fiber size, potentially muscle fibers. And again, lack of exercise leads to, or lack of exercise leads to muscle atrophy. And so we as normal, if you will, take for granted the fact that, you know, if we just move, we'll see an increase in, we'll see muscle hypertrophy. Whereas these individuals have a disorder that triggers muscular atrophy or the degradation of muscle. So you're asking yourself, well, what happens, what's associated with this loss of muscle with aging? Immobilization, leading to bed rest, fractures, frailty, chronic disorders such as cancer, congestive heart failure, COPD, chronic obstructive pulmonary disease, and muscular dystrophies, which has been shown to affect 500 to 600 male newborns annually. Immune disorders. Here are some case studies of how exercise has benefited those living with muscular dystrophies or muscular disorders. So there was one study looking at aquatic exercises, and what they found was that there was a young man named Ali, and because he was going to swim class or going swimming on a regular basis, it improved his quality of life, enhanced his self-perception of who he was. It allowed for him to be more connected to other individuals, so it fostered socialization, and a typo there, initiated relaxation as well. In another study, they had 11 subjects, and what they did, they had them do a step test where they did 20 steps up and down on a 20 centimeter high bench. And what they found was that as a result of them doing this 3 times per week for, I believe 8 weeks it was, there was an increase in the signaling, in the muscle signaling and the strength intensity in several muscles. For instance, they saw an increase in their vastus lateralis. They saw an increase in the medial and lateral head of the gastroc. They saw an increase in their rectus femoris. They saw an increase in the biceps femoris. They saw an increase in their muscles, and you can look at their articles later on. But there was a major increase in their contractility and the strength in their muscles. Another case study where they looked at using the limb girdle muscular dystrophy model. They had 24 subjects and 27 control subjects. These were all human subjects. They used electrical stimulation and exercise as their groups to study. They had an 8-week study. They looked at the effects of the electrical stimulation on the quadriceps or the rectus femoris and deltoid. And what they noticed was an increase in significant muscle strength post this 8 weeks of electrical stimulation and in the exercise group. They also saw an increase in significant endurance in the endurance test, a significant increase in endurance tests in the electrical stimulation and the exercise group. They saw an increase in efficiency in their activities of daily living. The groups were able to, the subjects were able to improve in their climbing upstairs, walking 10 meters, and even putting on a shirt over the period of this 8 weeks. These are my references. This was a great time. I hope you learned something. I look forward to having more discussions with you. Till next time, have a wonderful day. Be blessed. Keep rocking on out.